Hey everyone, it's David Bomble coming to you again from Oxford in the UK. Really happy to be talking to Mr. Hank Preston again. On our previous call, we were talking about Git, but we didn't manage to finish that. So, Hank, welcome to the call. Good to have you back again. Hopefully we can talk more about Git.
Absolutely. It's always good to be back, David. And it seems like we always set out with the best of intentions, and then our dialogue and questions get so good, and,
Yeah.
and we always roll over. So, but I think that's good. The audience seems to like the content and the detail we go into. So,
No, I think so. And I mean, on that point, please give us feedback. If any of you have suggestions of topics you'd like me to ask Hank about, or any questions about the information that we're sharing, then put comments below this video. Let us know what you think, and are you enjoying these videos, and how can we improve them and make them more beneficial to you. So Hank, with that said, I'll hand it over to you. Let's learn a bit more about Git.
excellent. Yeah. So hopefully, if you didn't get a chance to watch the last video, that's okay. We're going to pick up from there and do some different pieces. But the last one was all about kind of using GitHub and the tooling and understanding how to work with it, look at issues, look at kind of who made commits, the value that Git offers, even outside of for code and development, for any types of templates or scripts that you might be doing. What I want to go through today is kind of show an example of how, as a network engineer, you use Git on your workstation to build code, contribute back to a repository as it goes through. And so for that, what I thought we'd start out with is I'm going to add an example bit of code to one of the code samples that we have up on Cisco DevNet. And so this is the Cisco DevNet Python code samples repository. And what I'm going to do is we're going to add another example. So this repository, if you look at it, we've got a series of code samples for both on-box. So on-box Python script is Python code you would actually execute on an end device. So on an iOS or NXOS device as it goes through. You can see we have a series of examples. And then we have some off-box examples. These are ones you would run like on your laptop to connect to the network devices using a protocol like netconf or SSH, or as you can see in here. And we have a series of those. So I'm going to add a new code sample for an off-box Python that we goes through.
Hank, can I just stop you? This
Oh, yeah.
code, is this freely available for anyone to have a look at?
Absolutely, absolutely. All of this code is up on DevNet, and it's intended to be open source for anybody to use directly as it is, as examples for your own projects, inspiration. You'll notice we've had 120 stars, which indicate 120 people have at least clicked the star button. 81 people have forked it, and we're going to talk more about that because I'm about to fork it myself. And then 66 people watching it. So these are just regular code samples for working with the network over Python. Completely free, completely out there for anybody to take a look at and use.
And I don't want to diverge too much, but I'm just going to mention it.
Mm-hmm.
When I was at Cisco Live, you mentioned, and a few other people mentioned, the code exchange. So on developer.cisco.com, so the DevNet main website, there's this code exchange thing as well. So people can get code from this GitHub repository, but they can also get it from your code exchange, I believe. Is that right?
Yeah, and this repository actually should be up on Code Exchange, so we'll go take a look at it there. And we are nothing if not consistent with our diversions, so that's all
yeah,
good.
sorry, but it's like great, these resources,
Yeah, so here Code Exchange, as David mentioned, it's a place for anybody to share. So if you've written some code, some interesting bit of example that deals with something related to networking or Cisco technologies in general, you can submit it. Anybody can submit them. You just need to provide the GitHub URL, and then what we do is we curate those so that you can find them, find interesting bits of technology for the different projects you're after. And the example I always give is if you go to GitHub and you search for iOS, wanting to find something to work with Cisco iOS, you'll probably find a lot of examples for Apple iOS, because that's what you're going to really find if you search for iOS on GitHub. Whereas if you search here for iOS, it'll be Cisco-related iOS pieces. But let's see if that code repo, that Python code samples, I think is what it's called, which should be posted. Oh, maybe it's not. So if it's not, I need to get it posted. So I will go ahead and get it here. If I look for, I know some of mine are up here, so if I look for Vagrant for an example, here we've got a repository I've posted, Vagrant NetProg. Vagrant's an open source tool for working with virtual environments and managing them really easy for development. So I built a set of code repository for working with Vagrant for network devices. So how to build Vagrant boxes, how to work with them, some labs that go along with it. And we can see some other examples here. And again, all of the code up on Code Exchange is, again, open source, completely free. Anybody can use it. And some of them will come from Cisco repositories, like this one here is from Cisco DevNet, but this one's from me, H. Preston. You'll see some from the Cisco SEs. You'll see some from different folks that have done labs for us. I was looking for one that I knew wasn't a Cisco person. So PEH Rubry here, I think he's a partner out of the EU. And so I've worked with him on some different pieces. So he's got some code samples here. So like I said, anybody can submit a code sample if you've built something that you want to share.
That's great. I mean, sorry to diverge there, Hank. It's just nice to see, sample code. It's easier to copy someone's code and edit it than to try and create your own. So brilliant.
Yeah, absolutely. All right. So I've got this Python code samples. Now I work for Cisco DevNet, so I could actually edit this repository directly. But let's say I didn't work for Cisco. Let's say I was a student or a partner or just somebody interested in this pieces, and I had an example bit of code that I wanted to provide. You could think of this like any other open source project. The first step here is what's called forking the repository. So this version of the repo exists under Cisco DevNet. We can see it here. If I fork it, it gives me the ability to make a copy of the entire repository into another location. And you can see I'm a member of a handful of organizations. I'm going to just store it underneath my own account, H. Preston. And so it comes up, it says we're forking the Cisco DevNet. It only takes a second. And forking is exactly it. It just takes a copy of it, sticks it in my own repository. And so now we see I'm under H. Preston Python Code Samples Network. And GitHub knows that it was forked from this other location. And we'll show, by the end of this video, the goal is that we'll show how we can actually send this suggestion back up to the original, what would be called upstream repository, the Cisco DevNet one, so that it could be included there. So I made a copy on GitHub. What I need to do is get this code down to my laptop so I can work on it. And so we can see I've got this green button here for clone or download. And so if I click on that, we can see that I can go ahead and clone. You can clone with either SSH or HTTP. GitHub always defaults to SSH. I prefer HTTP, so I'm going to go ahead and clone here. And so I copy the path. And so if I look at what I just copied, I copied the URL for this repository and then .git. And so it's just the path to it .git, and that's the kind of the representation of this repository. So the little copy button lets me copy it to my terminal or my clipboard. And then I switch over to my terminal here. Let me make the font a bit bigger so that we can see it okay. All right. So here I'm on my terminal. I'm going to change into what I have. I have a directory on my laptop just under my home directory called code. And this is where I put all of my different code examples. And if I look, you'll see that I've got lots of repositories for different types of projects. Now the first git command we're going to use is git clone. Git clone copies down a repository from a remote location. In this case, the remote location is GitHub. And so I'll just paste in that address that we copied. So we can see we're cloning down from github.com. H. Preston is the org or the account, that's me. And then Python code samples network.git. So that's the address that I'm going to clone. Oh, apparently that one already exists. I've done part of this already. So we're going to go ahead and I'm going to delete Python code samples network, remove that directory, and we'll try again. What the clone option or the clone activity does is copies it down into a directory called the same as the repository, which is why that didn't work. So here, now I've cloned it down into Python code samples network. And if I change into that directory, Python code samples network, we'll see that I have the full copy of that repository from GitHub now on my workstation. Now, where did this come from? This is a Git repository. So Git on my laptop here, I can interact with it. So if I do git remote-v, so remote is the linkage back to wherever this original source was, what remote source it came from. And the -v is for verbose. And so we can see the origin of this was again from github.com/hpreston Python code samples network. So this is where it came from. Now, I want to edit and make some changes to this repository. Now, I could do this through the terminal and use VI or Emacs, but I'm not that much of a hardcore developer, so I use Atom as my editor of choice. Now, there are lots of code editors, Atom, VS Code, PyCharm. This just happens to be the one that I'm using these days. And so inside of Atom, I'm going to open up that folder that we just cloned down. So from my laptop here, I'm going to go over to the code directory. And then I've got here Python code samples network. I'm going to open that up. I can't make the the window or the tree view over here much bigger. So hopefully, but the editor here should be big enough that we can see. Now the first step I'm going to do is I'm going to create a new folder for my code example. So I'm going to say new folder, and we're going to call this NetMiko interface example. So I've created a new folder. There's nothing in there yet, but this is going to be the housing for all of the code examples that we're going to create. And so the first code file that I'm going to put in there is going to be a file called, and I'll create a new file underneath here, and we're going to call this device info, info.py. And so we can see, if you can tell in the recorder, maybe David will be good enough to edit and zoom in a little bit. Inside of my code editor here, these have turned green. What the green indicates is that Git is monitoring this repository as I'm working. And it's noticed a new file has been created. Green indicates a new object. So at this point, it's a new file. We haven't done anything with it yet, but Git is notifying us that there's been some changes that are out there. All the rest of the files are gray. Gray means that Git says those are still in sync. There's been no changes to them. They're not new. They're just exactly as they started. And this helps you as a developer to keep track of what changes you've made as you're working on a particular project. I know there's been plenty of times where I'm knee deep, maybe 4 hours into a project, and I've touched a lot of different templates. I've touched a lot of different pieces. I may not remember every file that I've touched. Git makes it really easy to keep track of which files have been changed, just with this little color change that's there. Now the device info file, now I am cheating a little bit. I'm not going to live type.
Can I interrupt you, Hank? Sorry.
Oh, yeah, no, please do.
Sorry. So a few questions. That green option that you're displaying there, that you explained, is that something that Atom's doing, or you're running a Git process or something that's monitoring it?
No, that's a good question. So the color change is the way that Atom is reacting to what Git is doing under the hood. So if I switch back to my terminal, so here I'm on my terminal, and if I type git status, it's actually a really good question. I should have covered this. So git status says, okay, I'm on branch master. So we might talk a bit about branches today. We might save off that for another call.
Okay.
But this untracked files, this is where Atom knows to turn that green. It says, hey, there is an untracked, it's an entire folder from Git's perspective because none of the files are being tracked. But there's this new folder that was created, NetMiko interface example. Untracked means that we haven't instructed the Git repository to monitor that file or the files that are in there yet. We'll see as we go through the example, we'll have other Git status will give us other things that say modified files. So once Git is tracking a file, which basically says we've added it to the repository, it monitors all those files for changes. And if there's a change, they'll come up as modified. And we'll see Atom represents modified files with like a yellowish color. New files are green, modified files are like a yellowish color that we'll see as we go through. All IDEs have some way of visually showing the developer those types of changes as you work. That green-yellow color is just how Atom does it.
So forgive me for being a bit dumb and slow, but you installed Git on your computer, and then you did a clone of a repository, and that's how Git knows to monitor that directory. Is that correct? Or
Yep. So we installed Git, and we can talk a little bit at the end, and you can figure out if you want to move it around in the editing. Installing Git's really simple. It's actually mostly, if you're a Mac user, it's basically already installed. You just need to kind of accept the license, and you're ready to go. If you're on a Windows machine, it's a downloadable that you just download from the web and install. And Git itself is open source. We talked about that in the previous call.
Yeah.
Once I've cloned down the repository, if I do an ls-la, and so -l lists out all of the directory that we're going to see, and then a says all, which basically says show me the hidden files. And so what you'll see is there's this directory in here called .git. So the .git directory is kind of the database or the configuration information about the repository. So all of the fact that this is a Git repository is all understood because there's this .git directory. And in general, I tell people try not to mess around inside the .git directory because that's where it stores all of the diffs and the hashes and the history of the entire repository. And in general, you don't want to directly work with those files at all. The one exception is that underneath the .git directory, there's this file called config. right? There it is. If I highlight it, struggling to highlight today. There's this file called config. That's an easy enough one to look at. I usually don't edit it directly, but if I just use like the cat utility, which just prints out the contents of a file, and do .git/config, you'll see it's just a text file that has all of the details about the repository. And so remember, I ran that git remote command. What that did was the git process looked inside of the config file, and then Chuck looked here, right? It says remote origin and said, okay, here's the URL. And so the fact that it's a Git repository comes down to the fact that there's this hidden directory .git that contains all of the context and metadata. This directory came down when I cloned the repository. It was kind of created by the process of cloning it down and in keeping track of all of the pieces. And as I said, you can see all of these other directories with info and logs and objects. You can look at them, but if you start manually messing with those files, you could damage the repository. Not on GitHub, you would just damage it like on your local workstation. Does that make sense, David?
Yeah, it does. So, I mean, just to summarize, make sure I understand, you basically copied, I'm going to use like layman's terms, you copied a directory from the web to your computer using Git. Git is an application running or a process running on your Mac in this example, and it's monitoring this directory for changes. Is that correct?
It is. The one piece, so to start out, copy to directory, 100%. That's what we generally work with. But along with the directory, I also have all of the history of all of the changes that ever happened.
Okay.
And so we saw in the last video inside of the GitHub URL or web interface, we could look at the history of the commits. Yeah. I can do the same thing here now locally on my laptop. If I do git, I think it's just log. Yep, git log. Now this is giving me an output of all of the commits and changes that have happened to this repository. And remember, I forked the repository from Cisco DevNet. It's now I'm looking at it, my version of it. But when I forked the repository, it didn't just take like a snapshot of the current state. It actually brought over all of the changes, including all the contributors that are there. And so you can see a coworker of mine here, Joe Clark. He made some changes at some point on this repository. You can see some of the ones I've done as well. We can see Krishna has done some changes in this repository. And if I just scroll down through, you'll see it's got the entire history. This history information is some of the other stuff that's in that hidden .git directory. If we went like trolling through the folders, we'd eventually find where all this data is stored. But the much more efficient way is to use the Git tools, commands like git log, to look at the history. And this is a very convenient one because you can look at the last few commits. If I scroll back to the top of the log, you can see this. There's some in here. I was actually doing some fixes on this repository this morning. So we can see some changes I made. Before I made those changes, Joe made his change back in February. And then there was a bit of a gap before the last change that happened to be me that was out there. And so the reason I bring that up is copy a directory, yep, but it's also all of this history. And it's really, it's that history, it's the changes to the files, which is what makes Git such a powerful tool for us network engineers, because we know who made changes, when they were made. If you needed to, you could actually go back in time and say, you know what? The change that Hank made this morning was terrible. We're going to go ahead and we're going to pull that out and we're going to revert to the state of this repository before that change that was there. Those are some more advanced pieces, but these are some of the values you get when you're working with a tool like Git for source control. Yeah,
that's brilliant. So, I mean, I'm a bit slow again. So we forked it. So we basically copied it from DevNet to your what do you say, cloud-based
my account. It's my account
on GitHub. And then you copied it or cloned it down to your local computer. So we're working on a local copy on your computer now. And then at some point, hopefully, you'll send it back to your H. Preston on GitHub and then push it back to DevNet. Is that kind of the idea? Yeah.
That's exactly what we're going to go after, is to show kind of this entire workflow of contributing to a project.
Brilliant.
Okay. Awesome.
Hank, we always take longer because I ask you a million questions.
No, they're great questions. I've taught Git so many times, so sometimes I forget to dive into some of the fundamental pieces. So please keep asking the questions. All right. So remember, what we've done is I created a new file called deviceinfo.py. It's blank right now. And so what we're going to do in this file is it's going to store details about different network devices that I might want to code against. And as I mentioned, I don't want to make everybody watch me type, so I'm going to do a little bit of copy and paste magic and bring in what I want the contents of this file to be. So this is a Python file. There's some stuff in here that we'll talk a bit about. If you haven't seen a lot of Python files with some of the bits that are here, there might be some stuff in here that seems a bit kind of out of the way or just extra. In a Python file, or actually in most code files, the first line is something that is called, let me see, I can make this a little bit bigger even to go through. So it's a little gray, so it might be tough to see, but this first line here is called the shebang line. So it's the hash symbol and then the exclamation point, which is sometimes called bang. I don't know who started that, but it's called the shebang line. And what the shebang line is used for in a script is to indicate what type of script this is. And so this is a Python script. And so what we see here is it says user bin env Python. And so this instructs something that's running this script that this is a Python script and it should be executed with the Python application. So the first line is the shebang line. It has to be the first line in the file. And so other examples is you might see a shebang line that's like bin bash if it's a bash script, or if it's a PowerShell script, it might say a PowerShell indication. But it's this common part across lots of different scripting to indicate what type of file it is. Then we have this block of green text in my editor. It starts with 3 double quotes and then ends with 3 double quotes. And this is called in Python a doc string. And it's just a description of what this file is supposed to do, along with any licensing or pieces that goes through. And so Cisco has a standard kind of attribution that they have us put into sample code. So this just says this is a piece of sample code. You can use it, you can do whatever you want with it, but you can't, there's no liability attached to it, right? So if something goes wrong with this script, you can't call Cisco up. It's like a typical open source style license that's there. And so this has just been stamped in to what's there. After that, we have a series of 4 variables. Now these are kind of, they're not required for Python scripts, but it's one of those things that has kind of been stylistically brought up by Python to make indications about it. So we can see that I've got a double underscore author, double underscore, and then author email, copyright, and license. And so these are just providing context about this script, and there's kind of a boilerplate that I use for a lot of my sample scripts. This use of double underscore and then a variable name and then double underscore is inside of Python. It's a style that's kind of grown up in the language that indicates that these aren't necessarily variables or resources that will be used directly by coders. It's there for internal use or some sort of documentation like these. And the way they're referred to is dunder, because double underscore author double underscore is a lot of words to say. And so it would be dunder author email, dunder copyright, dunder license. That's just kind of the way that the Python ecosystem or linguistics have kind of grown up. So these are just setting some variables about what's there. So almost everything for the first 30 lines of this is just boilerplate code that you may see show up in code at the top. That's what it's there for. It's kind of this documentation of what's out there. The interesting bits of this code are what's down here at the bottom. And so I'm just creating 2 dictionaries that I will import into my actual code script so that, and the idea here is I'm going to have several code examples, and I don't want to have to put the information about my devices in every code sample. Or if I change something about those devices, I don't want to have to update every code sample. And so I just create them once here in this device info file. So I've got iOS XE1, and then I've got another one called NXOS1. These are Python dictionaries, and so I've got an address key, which is the address for the device, the port information, username, password, all of those. And so both of these devices are DevNet always on sandboxes, which means these are accessible directly over the internet. As the name indicates, they're intended to be always on and always functional, and they're used for things like code samples, which is why for me it's okay to put the username and password directly into a script that I'm about to put on GitHub. In general, for production code or your own systems, there are better ways to do credential management than just putting them directly in the script. In general, this is not something you would do for production, but for lab and learning, it's where it goes through on that.
Yeah, Hank, I just wanted to say, I don't know, we can make this offline or leave it in the video.
Mhm.
That might be great for another call. How do you do credentials
Yeah.
better in Python?
It is, and certainly worth going through. It's actually one of the, and I mentioned, I think before we started the recording here, I host a webinar series for DevNet called NetDevOps Live.
Oh, yeah?
It's a weekly series that goes through. We cover a bunch of different topics, and one of the episodes this season that starts in just a couple of weeks is on security best practices for scripting, and this is one of the topics that's going to go through there. And so that's something we can share with the community, or as always, we can certainly talk about it on our own piece. And kind of, you do a great job at helping me answer really simple, or the questions that are out there, make sure it's super understandable. So we'll have a
Yeah,
couple of options where we can share for more details on that.
that's great.
Awesome. So I've got this file here, device info. It's got my details about my two different types of devices that I'm going to be working with. So I'm going to save this file. Okay, so I've saved the device info file. Now let's go ahead and commit this into the repository now that I've got the data that I wanted. So I could do this through Atom. Atom has some ability to right click and do the Git pieces, but frankly, I find that it's just easier and faster to do this right from the terminal. So I'm back over here on the terminal, and if I do that git status command, we'll see that I have untracked files, just like we saw before. Now it shows the whole directory because all of the files in that directory are currently untracked. So I'm going to do git add netmiko. You know, I'm actually going to change into that directory first because that's where we're going to be working. So I'm going to change into the netmiko interface example. And now if I do git status here, it shows untracked is the current directory. So this dot indicates the current directory I'm in. So that's untracked. Now I could add the whole directory. So git add dot, but I'm going to add device or file by file. So git add device underscore info.py. And so I've done that. And now if I run git status again, we'll see changes to be committed. And so what we've done is we've said, okay, we've added a file and put it into a kind of a workspace or a staging area that says we're getting ready to commit these. We're getting ready to lock these into the repo. Basically put a stamp that says, remember what this current version of this file is, who made the changes, kind of all the history about it. And so it's ready to be committed, but I have to commit it still. And so git add, right, it staged it for commit. Now I'm going to do git commit. Now I'm going to do -m because every commit needs to have a message. Remember when we looked at the git log, there were little messages about what those commits were for. And so what we want to do is the message should tell everybody else on your development team or whoever's looking at the log, what was this commit all about? And so this one was added device info file for examples. So it's just a message. So we can see now I get some information back. It says, okay, I've added device info file for examples. That's the name of it. It tells me that one file was changed. There were 54 insertions. That's how many lines. There were 54 new lines put into this file. And then there's just some mode information that's put there. So now if I do git status once more, we'll see that I'm on branch master. And it says your branch is ahead of origin master. Origin master, again, represents where did this repository originally come from? Well, it originally came from my GitHub, H. Preston's GitHub. And it says I'm ahead by one commit. Because when I committed it locally on my workstation. It hasn't made it up to GitHub yet. To make it to GitHub, we need to push it there. So git push will send this commit from my workstation up to GitHub. Now to do that, I need to log in. So H. Preston. And then it's going to need my password, but I've got two-factor auth turned on, so I'm going to temporarily shut down sharing so that we don't capture my password here. So two-factor authentication is always, or in general, is being encouraged for most folks. And for Cisco, to have access to the corporate repositories, I have to have two-factor authentication turned on for my repository. So I went and I grabbed my current PIN for that, and I will put that in. And so now I've authenticated and it's gone ahead and the messages here. So it says counted objects, 4 new ones, a bunch of just output for compression. And then we can see that it pushed up to H. Preston Python code samples network. So now if I jump over back to the web, let's take a look and see if it's there. So I'm going to refresh the page here. We can see that I have the latest commit here was from H. Preston, added device info file for examples. That's why that message is so important. It shows up in so many places. Now I can click on it and it'll actually show me what the changes were. It says one changed file. Here's that file that was changed. Here's all the differences that were there. Because it was a brand new file, everything is green. But as we saw in the last video, as files are changed, you actually get to see indications of new lines or changed lines and who made those adjustments. If I go back here, I'll just go back to the repository itself. We'll see that I also have the folder in here someplace. Where is it? NetMiko interface example. And so here's that file, deviceinfo.py. So I've now pushed it up to my version of GitHub. It's not on the original one, Cisco DevNet Python code samples yet. I don't want to send it there because it's not ready. My example's not done. Well, once we've put all the pieces in there, that's when we're going to send it up upstream. For now, it's just sitting in my own code repository. All right, questions, David?
Yeah, I think that's great. I mean, Hank, I think what's brilliant about what you've demonstrated here is it's not as complicated as it sounds. It's Git it sounded like weird development stuff, but I mean, basically all you did was copy something down, you edited it in a IDE, or you didn't have to do it that way. Like you said, you could have done it through Notepad if you're on Windows or something. Mm-hmm. You added a file and then you just pushed it back again. I mean, You made it look simple, so thanks for that.
No, absolutely. And you know what we'll do is I'm going to keep track. I'm going to open up just a blank file here of the Git commands we've talked about.
That'd be great.
And so we've talked about git clone, right? And so what does that do? So that copies a Git repository from a remote, aka GitHub, to your local workstation, right? So that's what we've done so far. That was the first step we did. Git status looks at the current status.
Just going to say, Hank, can you email me this document when you finish? Because I'll add that below the video so everyone can easily copy that.
Mm-hmm. Includes new and changed files, and if you are ahead of upstream. We looked at git add. This adds changes or new files to stage and ready to be committed, aka locked. And then we did a git commit -m. And I'm going to do this too. Git add, and then it was you had to put in the file or directory. Git m, and then you had to give it a message. And then this locks in a change to the repository. This is why I don't type live very often.
I don't blame you. I'm the same.
Locally.
But this shows, I mean, for everyone's benefit, this shows you that this is real. I mean, Hank is doing a lot of the stuff on the fly, which is great. Mm. That's why we have mistakes, but I mean, it makes it more real, I think.
And then we haven't run it yet, although I'll type it here and then we'll go run it. Git push is to send changes to GitHub. Git pull retrieves, aka pulls, changes from remote to local. And so that's kind of the opposite. So there's push and pull. And so if you're working and you make changes, you push them up. Now, if you're working on a team and somebody wants to get those changes down that you've made, they have to pull them. And so if we were working together on this example, we would be pushing and pulling. And so I can over here, I'm just going to clear my screen. I can type git pull and it will try. Now, there's nothing to pull down because nobody else has made changes to the repository. But if there was, it would go through. And I can actually fake a change just so we can see how that looks. And so up here on GitHub, now normally you edit files and make changes in an editor offline like we've been doing here. But you can directly here within GitHub, you can edit files. So I've opened up this file. It's the one I created. I'm going to edit the file. And I'm going to, down here in the bottom of the file, I'm just going to add a comment just so that we can change the file. So sample GitHub editor comment. And then you can see I have to commit the change, right? I have to, so if you're editing directly in GitHub or any of these editors, you have to make the commit right away. And so I'm going to do the message, right? So here's the message. You can see you can do a short message, or you can do kind of a longer message if you want. We'll just do a short one. So demo editing on GitHub for git pull example. Oops. Try to type somewhat correctly. And then you can see I can commit directly to the master branch or a new branch. We're going to save discussions on new branch for another call. That's a bit too much to squeeze into one. So I'm going to commit changes. And so now I've updated the file here. We can see there's a new commit here, demo editing on pull. It's listed in the repository or in GitHub. If I scroll down, we can see here that here's that change to the file. If I go look on my computer, so where is that file? Here it is. Down here at the bottom of the file, right, there's no extra line. You can see that, David? Right?
Yep.
So if I come over to Git, now Git status, right, as far as Git status is concerned, I'm up to date. And that's because Git isn't constantly in the background, like checking in to make sure there's no changes. If you do an action, if I did something that had it talk to the GitHub remote, I might get some messages about that. But what you can always do is you can just do a git pull, which will then check in with the remote and see if there are any changes and pull them down. And so I ran the git pull, and we can see the first time I did it, it said already up to date. This time it said, oh, well, we make changes, we did some pieces, and then down here it said from, we updated, and then I even get a note about what was done. So netmiko interface example, deviceinfo.py, 2 lines plus. So there's additions to this file. If I flip back to Atom and scroll down, I didn't even have to refresh the page because Atom's a development tool. And so it's smart enough to monitor. So it saw the file changed. It didn't give me any errors, didn't ask me if I wanted to save over. It's one of the reasons using something other than a document editor when working with code is important, is so that you don't mistakenly overwrite changes. But Atom automatically brought in and said, oh, look, here's these two new lines that were there. Make sense? Questions?
Yeah, that's great.
Cool. All right, so I'll leave that in there because there's really no need to pull it out. All right, so I've got my device info. The next thing I want to do is to start putting the actual code examples that are there. So I have a series of example bits of code that we're going to use. And so the first one I'm going to do is going to be another Python example. This is going to be a netmiko example that knows how to check details about a particular interface, right? And so I'm going to go through and I'm going to create a new file. So over here in Atom, I'm just going to right click and say new file. And we're going to call this netmiko git interface.py. So I've named the file. It's blank right now, and I'm going to, through the magic of copy and paste, I'm going to grab the code and put it in. And so I've scrolled to the top. So like we saw before, here's that shebang line. Here's my doc string, and it's just, again, just a basic piece. It says it's going to retrieve information from a device. I give it some details at the top. And then we get down into the Python. So from netmiko import connect handler, import RE. This is regular expressions. Probably folks have stumbled across regular expressions, but it's a matching language so that you can try to find and pull details out of a string. I don't actually need the sys library for this example, so I'll delete that one. And then we can see from device info import iosxe as device. So let's talk about this one. So we created the device info file, right? That was the one we created before. It was deviceinfo.py, but we don't have to refer to the .py part when we're in our code. And then if we flip over to it, we've got this variable called iosxe1. And so what I'm saying is import the iosxe1 name. In this case, it's a dictionary variable. And then inside of my file, I'm going to call it device. So import iosxe1 as device. So now I'll have a new variable available to me called device, which is a dictionary that is based on that other file that's there. Does that make sense? Did I explain that well, David?
Yeah, that's great.
Okay, perfect. And then what we're going to do against this device is just send some CLI commands. And so we're going to create a template here, show interface configuration template, and it's a string, show running config interface. And then this curly brace is a very basic template indicator for a Python string. And we're going to use that in a second. Then down here, I'm using NetMiko to open a connection to the device. That's called a connect handler. I know, David, you've done videos on NetMiko. I've done some examples as well. So hopefully folks have seen this before. But this is a way to open a connection to the device. We're going to open based on the address, the port, the username, the password, device type. You need device type so NetMiko knows how to react to it so that it fits a Cisco device versus Juniper or Arista or some other device. And then CH here will represent our connection to the device. Now I have a template for my command up here. What I want to do is create an actual version of the command for a particular interface. And that's what this line does. So it says create a new string called command, base it on the template, but I'm going to format it by inserting loopback 103 into the placeholder that was there. And so then I will have show running config interface loopback 103. We'll then use the connection to the device to send that command and store the output as interface. And it'll print that interface here. It's then going to go ahead and use regular expressions to parse through the output for the desired data. Now this is going to assume that this assumes that that interface exists out there as it goes through. So we'll see. We might get some errors if that interface doesn't exist initially. All right, so that's our script so far. Makes sense? Questions?
Yeah, I was just going to say, Hank, I mean, you and I have both created content that explains NetMiko and Python in a lot more detail. So if anyone's struggling with a Python code, refer to free videos on my YouTube channel or, my courses or the courses that Hank has on DevNet. I'll link some of those resources below this video. I mean, this call is more about Git than detailed Python code.
Right. I just didn't want to throw the code up there without at least talking through it.
I appreciate it.
Yeah.
But what I like about this, Hank, is that people can copy your code now. So
yeah, well, and it's going to be up on GitHub by the time we're done. So, all right. So I'm going to switch back, and so we've got the code. So if I do a git status, what we'll see is that I have a new untracked file, netmiko git interface.py. Now before I commit it, maybe we'll run it and see if it works. And so I'm going to do Python netmiko git interface.py. So we'll actually see. I haven't run this one specifically yet, so let's actually see what we get back. I have a guess of what it will come back with. None type has no attribute. So this output here looks a little weird. So config interface loopback 103. What is that coming from? Let's look at the code real quick. I'm printing. That would have come from here. So the output from the command looked a little bizarre. Let's rerun that.
That looks like an iOS device complaining about, instead of interface loopback 103, it's onfig interface loopback 103, I think.
Yeah. I don't think that interface actually exists on the device. Here we can actually look at that because I can connect to the device. So as I mentioned, this is one of our sandboxes. Let me make the text a bit bigger. I don't think this loopback exists yet. What I might do is just go manually create it real quick. Ooh, I may have hit a few more pluses than I meant to there. That's okay. All right. So here I've make it easy to give myself the password. Show IP interface brief. Yeah, so loopback 103 doesn't exist. That's the number we're looking at, right?
Yeah.
103. Yeah, let's go create it just so this code will at least work. So interface loopback.
Just so that everyone's aware, I mean, you are connecting from your home across the internet to a DevNet sandbox hosted in a data center somewhere.
It is. This particular sandbox actually is hosted in Galway, Ireland.
Might explain why it's a bit slower.
Maybe my internet at home has been a little bit wonky lately too. There she goes. Yeah, you can see it took him. It was just me. All right, so IP address, and we'll give it a 10.23.234.1. Oops. And then no shut. Though I don't know if that's needed on a loopback. All right, so exit out of that. Show IP interface brief. Fingers get ahead of myself. There we go. So now we have a loopback 103. So let's rerun our script and see if it grabs it. Now NetMiko is connecting over SSH just like I just did for my exact same workstation. So some of the slowness is going to pop into that as well. There we go. Okay, this looks better.
That looks great.
Right, so now we can see that we got, this was the output that came back. There's no attribute group. Oh, okay. So that's actually pretty decent. So what we've got here, so this is the config that came back from the command. Now I got an error in here that says, okay, no description group here. There's my dog barking. And so what it is it's looking for the description. And if you'll notice, it tried to do a regular expression search for a description on the interface, but you'll notice there is no line that is description. So the error here is actually just saying, hey, you told me to go look for a description. I didn't find one. And so we've got an attribute error here. And so if I look at the code, so here's one of the things where we could go through and we could make changes. So I'm not going to fiddle too much with the code that's there. What I'll do is actually, just so our demo works and the error goes away, I'll add a description. Config T, interface loopback 103, description, make code not break. Really good description there. All right, we'll rerun it one more time. All right, so we went through, we've got our full description. Now we can see the description line, and we got no errors this time. So the interface loopback 103 has it. So my code is working, and it works assuming the interface is there. So I'm okay with it in its current state. So I'm going to go ahead and lock this in. So I've updated. We now have a description on the interface, and so we can see the output here, and I got no errors that were there. And so I feel pretty good about the code in its current state. Let's go ahead and lock it in. So git status. We can see that I have that untracked file that's still there, and I'm going to say, okay, let's go ahead and add it. So remember, git add stages this file for commitment. Git commit -m says, let's go ahead and say, I'm going to new file to retrieve loopback interface details. All right, so git status. We can see I'm ahead again. So if I do a git push, this will push this up. It is going to make me put my credentials in every time. You know what? Why it's not saving these this time. Hank Preston. There's my password. So we push these changes up. We'll check in on GitHub. Go back to the folder, and we can see I now have my new file. Right? So I've locked the file in that's there. Now, I want to talk a little bit about editing the files and how those go, and just kind of see what the reaction is. And so over here inside of Atom, here's my file, and we can see that it's all white. If I highlight off of it, there's no green, there's no yellow. But let's say I actually wanted to make a change in here. Now, we saw before when I ran this script, if there wasn't an interface in there, I got all sorts of errors would pop up. And it would cause Python errors. And so what I'm going to do is I'm actually going to put in just a bit of code here that will test and only kind of will give an error message, like a more friendly message, if it's unable to go through. And so the Python code for here is what's called a try except block. And so I'm going to put all of this inside of a try keyword that says try. So it's going to attempt to do that. And normally you would be very explicit about the exceptions, but I'm going to be fairly generic here for our call. So except exception. And I'm going to say, so what it says is run this code. If there's any Python errors, it's going to run whatever's in this except block. And I'm going to say print, there was an error, loop, it's just there, loop. Back 103 might not exist. All right, so I put that in there. And so what this should do is now if there's an error, it should go through and print that out. So let's run the code again and see what we get. So git commit, here's my code. There it is, python.nico. Now the interface does exist, so the code should work fine, but what we'll do is we'll go remove the interface and see if we get that error message. All right, so it worked, and we're in good shape there. If I come back to my device, and I'm going to say, let's get rid of that interface. Config T, no interface, loopback 103. And show IP interface brief. All right, so loopback 103 is gone. And so now if I rerun the code, with luck, we should get that message that says, hey, there was an error, loopback 103 might not exist. Yeah. And we did. Look at that. The code actually did what I thought it was going to do. So now let's look at what the status is. So we didn't create a brand new file. We edited a file. So our git status actually says modified. So we say this file has been modified. Remember, before we saw a new file. Now we're indicating, hey, this file, Git was already tracking it. It was already paying attention, and it's noticed there's been a modification. If I go over to Atom, we'll see there's some indications that Atom, and again, most IDEs have some way to do this. If you're not using Atom, there's probably some indication. So the first bit is the file turned this yellowish gold color, and that's an indication in Atom that there's been some change to the file. And if I look inside of the editor, you can actually see there's this, hopefully you can see it on the recording, there's this orange line that kind of goes over.
Yeah, you can see it.
What the orange lines indicate is which lines actually had changes in it. So not only does Atom tell me that there was a change to the file, it actually shows me which lines changed. So that's handy from an editor perspective. Now, how does Atom know, you might be wondering? Well, Atom knows because Git knows. And so there's another command we're going to look at from Git, and let me clear my screen, called git diff. And I can give it the name of the file I want to diff. And so you may have run across diffs before. It's not just a Git thing. And it's a way to look at the differences between two different files that are there. What git diff does is says, hey, take a look at the file that I give it here, in this case, and show me the differences that that file has from what was last committed. And so when I run it here, we can see we get the git output. The git output says, okay, it ran a diff here, and so we can see kind of the function that was run, the starting file and the ending file. It's the same file in this case. And then we can see, okay, these red lines indicate things that have been pulled out of the file. And so those lines were pulled out of the file, and these lines were put in. And if I scroll down in the diff, we'll see all of it. So the minuses in the red indicate stuff that was taken out of the file. The pluses and the greens indicate things that were added to the file as that goes through. And so the Atom view, that little gold line, is really just monitoring Git under the hood, and Git is what actually has the knowledge that this file changed. Does that make sense? Questions?
Yeah, it's really nice to see how the IDE and Git works together. Do you know if other IDEs do something similar, like PyCharm and stuff?
Yeah, nearly every IDE that's intended to be used for some type of development, whether that's a true app developer, or like I like to call myself, an infrastructure developer, any IDE is really going to do this. And so PyCharm does this, Atom does it, VS Code does it, Emacs does it. Even if you're a hardcore editor with like Vim, VI at this command line, that has plugins that can monitor and do this type of work.
And they all use Git under the hood for that kind of stuff.
Yeah,
that's great.
Yeah, they're all just taking advantage of Git under the hood. All right, so we made a change to the file as we saw. So Git status, right? It's modified. Let's go ahead and make add and commit this again. So git add netmiko git interface git commit -m, and so this time added try block for better error handling. Now, one thing we want to show this time is you don't have to push after every commit. You can actually do lots of commits on your laptop locally and then push them all up kind of as a bulk commit as it goes through. And this is really handy if you're working offline. Developers oftentimes will work someplace where they may not be connected to their corporate environment and have access to their source control system. Or in some cases, I've actually done development while traveling and I don't have the internet and can't get to public GitHub. And so I can do a lot of work adding and committing all locally on my workstation, and then all at once push all those changes back up to the remote. And that's what we'll show this time. So I'm not going to push yet. I'm going to go ahead and push later. And before I forget, let me add in the git diff. So git diff, look at changes between current file and last committed version. Oh, so that's the next command we looked at. All right. Questions?
I think that's great, Hank. I don't have questions at the moment. I think that's really good.
Perfect. All right, well, let's add another example file then. And so the first example we did was to retrieve interface information. Let's look at one that's actually going to go ahead and configure an interface that's out there. And so what I'm doing is I'm cheating right now and looking at my file, my sample file, so that we can go through. And we are going to get rid of this. Oops. And don't need this or this or these. All right, that should be it. All right, so the new file we're going to create is called netmico. Oops. Create interface.py. All right, so blank file, and through the magic of copy and paste, I bring it in. So lots of what we've seen already. So the shebang line, the doc string, we're once again bringing in netmico. We're importing in our device information about iOS XE1. And now I'm going to be creating a new loopback. Lo and behold, I'm creating loopback 103, that one that we've been playing with already. And so I've got details about the interface. It's got a name, it's got a description, it's got an IP address, it's got a net mask. And then I need to create the actual CLI commands necessary that you would run if you were to create this interface in the CLI. And we've actually seen me type these ones already. So the interface config. So the way netmico works is it wants a list of configuration commands that we'll go through. And so I created a Python list. The first command to run is interface. And then again, I got a placeholder. So we're going to put in the name, the description, the IP address. Inside the IP address, there's two placeholders, one for the IP, then for the mask, and then no shut. And so we can see we're using that format piece. So this creates a list that's fully set up and ready to create my loopback interface. I then do my connect handler to open my connection to the device. I then send config set. That's a netmico function that takes a list of commands and sends them into configuration mode. You'll notice I didn't put in config t. It's because the send config set function of netmico knows that I'm sending configuration, and it puts us into config mode automatically. And then down here, it'll just print what was sent out. So this file looks pretty good. I feel pretty happy about it. Let's go ahead and save it. And I'll go back to the terminal. And if I do my git status, we'll see that I've got my new untracked file. Remember, we just created it. And let's run it and see if it works. Create interface.
Just wanted to check, Hank, you're not using APIs here, you're using SSH, aren't you?
Yes.
For connections to these devices, yeah.
Yeah, so when we were asking last week for things folks wanted to hear, someone had mentioned interfacing with devices using CLI was something that they wanted to see more of. And so I figured here this was a good way to kind of do both of them. And so we'll take a look at how we can actually interface. The sandbox that we're communicating with does have APIs. It's got netconf, it's got restconf. But in this case, we're just using CLI for it. And there it goes. And so here we can see netmico. I printed out the output. So this is actually what was sent. So config term was sent. netmico did that for me. I didn't have to tell it. And then this is actually what was sent and kind of how it looked on the device. So CSR 1000V, interface loopback 103, everything was done. I think I'm still open to the device. And so if I look, I can do a show IP interface brief once more. Loopback 103 is back. Show run interface loopback. And then we can see the actual config that's in there. So we can see it was actually pushed out successfully. And so our demonstration script was able to push those out, and it functioned and everything was fine. And so I again, feel good about it. I've tested it, it works. And so now I can do my git add netmico create interface, git commit -m, added create loopback script. And I've now locked that in. And if I do my git status, we can see that I'm good. It does report that I'm ahead now by 2 commits, and I will eventually push those up so they all show up on GitHub. Now there's a phrase that developers talk often about. It's called commit early and commit often. It's kind of a throwback to the save early, save often from my college days when Word would crash on me after 5 hours of typing some paper and I lost all my work. So save early, save often, commit early, commit often. Now, when you're working with code like this, we've seen how every commit is kind of locked into the repository with a date and timestamp, who made the change, and the details of the changes that were made. And so the commit early, commit often, what's actually better inside your repository is to have lots of small commits rather than one giant commit of a bunch of changes that were there. And that's because if you're trying to figure out which commit might have caused a problem, or if you need to roll back a commit for some reason, it's better to roll back small commits and kind of surgically pull out changes rather than have to weed through massive changes to figure out what might have caused the breaking change. So if we think about this, imagine you're a network engineer and you've got a standard template that you use to push out. And someone goes through and they say, okay, we're going to update the template. And they go through that template and they update ACLs, they update routing policy, they update VLAN configs, they update all over the file, and then they just commit that once. Well, now, if there's a problem with that new one, it may be hard for you to figure out exactly which change was made that caused the problem. But if they instead made those same changes, but they changed one bit of it, tested it, it worked, they committed it, they changed something else, they test, they commit, they go through. Now you can figure out which one of those changes might have made the problem. And so that commit early, commit often concept is every time you think you've gotten to the point where your script is functioning, you want to commit that and go ahead and push that through. Does that all make sense?
Yeah, it makes a lot of sense. I mean, I like the analogy of word crashing.
Yeah.
There's nothing worse.
No, and it does happen still to this day, although the autosave has gotten a lot better. All right, I've got one more script example that I'm going to go ahead and put in here. And so this one is, so we've retrieved information about an interface. Let's go ahead and delete information about the interface as well to kind of do the full loop that's out there. And so I'm just getting my code sample ready to go. There we go. So I'm going to add my third example, so new file. And I'm going to say, how about netmiko delete, we just did interface.py. Paste it in. So again, we've got our sample that's up here. We're using netmiko. The loopback we're going to delete is that same one we've been playing with, 103. My config set is a single line in this case, so no interface, and then giving it the name, and then going through. So very similar to the last one we had. We'll go ahead and I will run this code just to see if it works. Python netmiko delete interface. People sometimes ask me, why use an API like netconf or restconf? CLI works great. There's a lot of reasons for it. We're actually seeing one of them right now. The CLI as a programmatic interface is really slow. If we were doing these same examples, and I actually have these same examples of creating and manipulating this loopback interfaces with netconf and restconf, they're much, much faster because it doesn't have to deal with just the CLI and the SSH and the slowness that's there. There are other reasons, but speed alone is a good one that goes through. I did kill enough time. We can see that it's finished. It again went into config mode, ran this command, and now if I come over here and look, we should no longer have that interface, and we don't. And so we've kind of done the full life cycle of that file. Now before I add that and commit it in and we finally push these up, questions, David?
Hank, I mean, I think it's great. You've explained this really well. I'm not sure what to ask. I mean, I think you've covered it all.
Good. I always.
So, I mean, sorry, go on.
I was just saying I give you a chance to ask the questions whenever I think there might be a break, but the fact that you don't have any means that my explanations are getting better, I think. So.
No, it's great. I think I'll just open it to the audience. If anyone's got questions, as always, please post them again below the video. Maybe Hank and I have assumed something that you're not sure about, so let us know.
Yeah, absolutely. All right, so as we've done before, I made a new file, so git add, git commit -m, delete loopback script. And so now my git status shows that I am ahead by 3 commits. Well, I'm done with the code I'm going to do for now, so let's go ahead and push this up. So git push, put in my credentials, Preston. Oh, and it didn't take something, right? Let's try this again. Git push, H Preston. Oops. There it goes. Copy paste error the first time. All right, so I push those up. If I look up at GitHub, refresh the folder, we can see now I have all of the files are there, right? So my device info, my create, my delete, and my git interface. Now I am ahead, 6 commits ahead of the upstream location. So let's talk about the final step. Now we've made our code examples, we figured out that we wanted to make some changes that are in there, and I can go ahead and do what's called a pull request. A pull request is a request is a hard word right now. Pull request is a request to whoever owns another repository, in this case the upstream repository from Cisco DevNet, and says, hey, I've made some changes. I would like for you to pull them into your repository. And remember, pull is going from one location to another, right? So it's a pull request. So I click on the pull request button. It comes through and says, okay, it first tells me that, yes, if they accept it, this would be able to be merged into the upstream repository. The base repository is the destination, and the head repository is where we're coming from. So I'm the head. I'm a head is how I remember this. I'm a head of the base, and I want them to go through. And I can go ahead and create the pull request. Now, if I scroll down here, it'll actually show me what the changes are. So before I make the pull request, I can make sure, is this really what I want to send? So it's showing 4 changed files, and I can see all the bits and pieces. In this case, it's adding a whole bunch. If I had fixed or edited or made changes to code that already existed in the repository, we would probably see a mixture of adds and subtractions. But in this case, we're adding a bunch of new files. And so if I scroll, everything is going to be green because there's no removals, right? So that's showing all of the changes. So this one pull request is going to include all of the commits that I've done. Okay, so I'll scroll back to the top. So yep, that's what I want to do. I'm going to create a pull request. I'm going to give the pull request a title. Adding a new example for NetMiko and loopback manipulation. And say, this is a CLI example using NetMiko and the DevNet sandbox. So when you do a pull request to a repository, sometimes organizations, code owners will have a template and what they want to see in a pull request with descriptions and ways to go through. And large open source projects need to do that because pull requests can be a lot of maintenance and overhead for the code owners to go through. In this case, I'm giving it a fairly simple example to go through and say, okay, I'm going to create this pull request. Now the pull request is created in the upstream repository. So you can see I'm back in Cisco DevNet Python code sample network, and I've got a new pull request that's on this tab. So if I flip back to the code, right, here's the repo with the code. The pull request tab shows here's the pull request that I went through and did. And now I happen to be, as I mentioned at the start of the call, an owner of this repository. So I could actually go in here and I could merge this in because I have rights to this repository. If you don't actually get this merge button that's there. If I didn't have rights to the repo, I'd be able to come through and see it, and I could add comments to it. But as an owner of the repo, I have the merge button that's here. Now let's pretend for a minute that I didn't just submit this, but I was monitoring this as an owner of the repo. What I would do is I could come in here and say, okay, somebody sent me a pull request. I can look at the files changed, and I can take a look at their code. I can look at the individual commits that were made. Remember, I made a series of commits, and so I've got 6 commits that are all included, and I can check on each one of them. And then there's this conversation tab. The conversation tab is used in a pull request to go back and forth from whoever is submitting the code and then the repository owner if changes are needed. Now, I purposely actually left some things out of this that I know were needed so that I could use them here to show how this works. And so as the owner of the source repository, I can say, hey, I'd love to merge this in. Can you please do the following? So 1, add a requirements.txt file for all Python requirements. 2, add a README to the example folder describing what it does. And 3, update the main repo README to add the example to the table. Now, I am an owner of this source one, so I know these are the things that I would need before I would merge in from anybody else. And so I'm going to make myself go do these things as well. And so by adding a comment, now this is a little weird because I'm the entire conversation, but if this was a conversation between, let's say, me and David, right? David, you had sent an example, and you would get an email and a notification from GitHub that this communication was going on, and you could come back and we could talk back and forth about this pull request, so you could fix the changes or make the adjustments. And then once it was all done, I would hit this squash and merge button, and then take all of those commits that you made and pull them back into the upstream repository, finishing off kind of the entire process that's there. Now, we're out of time today for me to actually fix these changes, but hopefully that process makes sense as it goes through. Thoughts?
Yeah, I mean, that's great. I mean, so the only piece that would be remaining is you have to create those additional files, then you have to do the pull request again, and then the owner, in this case would be you again, would have to accept them.
Yeah. What's interesting here is the pull request actually is just a linkage back to my repository, and in particular, this branch called master. If I make the changes and put them back into and I just push them back up into my repository, the pull request is live. It actually would see those changes as they get done. So it wouldn't have to
Okay.
be a new pull request. It would be the same one. I would come back in here and say, hey, I've made those changes. Can you check it out? All right. So it wouldn't have to be a new pull request.
That's great. I mean, Hank, when we started originally, we were talking about lawyers using Git for documents. And I think what you've shown really well here is how, like just a standard like contract or like code that would be used for network devices can leverage Git and GitHub. So I really appreciate you spending the time showing us this. So thanks very much.
No, absolutely. And we got through kind of everything I wanted to in today's call, which is actually unusual for us.
It
Usually
is. It
I
is.
run out of time. So this was good. So as David mentioned, if anybody's watching the video and has questions on Git or how something worked, use the comments inside the YouTube video or reach out over one of the social medias in peace. Getting comfortable with Git, and I feel like I use the word Git way too often when in these ones because of the way it goes through. But becoming comfortable with Git as a tool is going to be really critical for network engineers, even before you get into the coding bits. As I mentioned, it's a great tool for managing config templates or anything that's part of the piece that's there. It gives a lot of power for those pieces. So hopefully everybody's inspired a bit, and we'll go get comfortable and take one of the learning labs or experiment with what's out there.
Yeah, I mean, just before we end off, Hank, do you have any recommendations of stuff that guys can look at next on the DevNet website?
Yeah, and so we'll include those in the links that are there. We actually did a video in NetDevOps Live Season 1 on using Git as a network engineer, showing more of these pieces and other examples, and that's a great video to check out as well. Yep, we do have DevNet Learning Labs on programming fundamentals that cover Git 101 and kind of help walk through some of these pieces as well. So those are great follow-ups to the discussion we've had today.
Brilliant. Okay, Hank, I know we're out of time, so thanks very much.
No problem, David. It was a blast as always.